the last video we saw about simple cloud architecture, right, where we got a requirement from one of the startup companies and where they wanted to serve some static pages to their customers, right? And also if there is a new request, they wanted to get that request, process the request, pull some data from the database and pass it on to the calling client, right? So this looks good as long as there is no issue with failures, right? Suppose if there is a failure on this API connect, what will happen? The request will not reach virtual machine, right? Suppose if there is a failure on the virtual machine, the request will not reach the database. And in case if there are any failures on this flow, and the request will be broken, right? So how do we address all these single point of failures, right? So let's see how I improved this simple cloud architecture to an enhanced cloud architecture, right? So if you look at this picture, this addresses a lot of issues that we saw in the previous diagram, right? So why we came up with this enhanced cloud architecture? Because in cloud world anything can happen. Sometimes the volume of request will be huge and your system should be in a position to handle that. And sometimes there will be a kind of distributed denial of attacks, kind of like multiple fake requests sent by some hackers to your system to slow down your system. So we have to handle that. And sometimes your DB may have huge transaction. So if you have a single DB like this, it may have a failure on high volume of transaction. So that is called SPOF, single point of failure. So we have to address many failure, right, point of failures. So that's why we came up with this improved or enhanced cloud architecture. Okay, so what I did here, instead of one zone, I kept two zones here. If you look at this, this is zone 1 and this is zone 2. Okay, so why we came up with this approach? Because in case if your virtual machine on zone 1 fails, the customer's request will be handled by the virtual machine which is on zone 2, right? In case if your database on zone 1 fails because of the high volume of transactions, your database which is sitting on zone 2 will handle, right? So for that reason we have two zones. Okay, and we didn't have any firewall, right, to handle any kind of hacker attacks or distributed denial of attacks. So those issues can be addressed with the web application firewall. Okay, so I put a web application firewall in front of the CDN so that any request that comes to CDN, it will handle first, it will be handled by the web application firewall. And once the request passes to CDN, if the response is already available, it will serve the response quickly to the customer. But in case if the response is not available and the request is new, it will pass the request to the cloud load balancer here. So the load balancer, what it will do, it will distribute the load across two virtual machines sitting on two different zones. Okay, so that the high volume of the load can be distributed between two virtual machines. And once that those virtual machines process those requests, and it will pass to the cloud load balancer, which is kept in front of the database instances, right? So what it will do, this load balancer will distribute the load between these two databases spread across two zones. In some cloud service providers, they call it as availability zone, and some cloud service providers, they call it as a zone. So I'm not putting all these diagrams specific to one cloud service provider. It is generic cloud service provider diagram. Okay, So suppose if you are familiar with Azure, you can think of zones in Azure terms. If you are using AWS, you can think this zone 1 as a availability zone 1 and availability zone 2. Okay, and coming back to the performance of the database, suppose if there are multiple huge volume of transaction during the Black Friday time or any festival time, right? The customer may get more volumes from their customers. So, so in that case, what will happen? You have to quickly serve the database responses to the customer. So what we can do, we can have a kind of read replica or Redis caching mechanism implemented, so that you don't need to call every time the database and make a complicated query to the database that is costlier. Okay, and so that is resolved by using this DB cache mechanism, and rest all the cloud storage and monitoring services, all those things are available as we saw in the previous architecture. So basically this monitoring service, what it will do, it will keep tracking your instances logs and analyze the logs and see if there are any flaws or failures in the log, and it will report to your monitoring tool. Okay, so IBM has AI infused monitoring tool that's called Cloudpak for Watson AI Ops. What it will do, it will read all the logs from your different cloud instances and then analyze those logs, predict what it is going to happen based on the information available in the log. So compared to this previous simple cloud architecture, this enhanced cloud architecture has lot of features that will save your application from many single point of failures, right? So hope you might have got to know about how to improve the simple cloud architecture to an enhanced cloud architecture. But the question is, do you think this enhanced cloud architecture will solve all the problems or all the failures usually that you see in any application architecture or any system? Let's see the answer for that question in the next video. Okay, so if you like this video, give a thumbs up and subscribe to my channel, and also if you have any questions, just put on the comment box below. We can discuss and be collaborative. Thank you, take care, bye.